and good afternoon, everyone. I welcome you all to India's largest e-learning platform, Unacademy. And I welcome you all to my session of EM Wave Propagation. Welcome you all to my channel of GATE Conqueror. Just kindly confirm the video and audio, dear. This is a very important session. This session is going to be a very important session, dear, because we are going to go through the numericals related to wave propagation in this particular class. Just confirm the video and audio once so that we can start. And also give me a moment to verify the same. Fine. There's someone kindly confirm the video and audio. So, try to keep your calculators ready, dear. Try to keep your calculators ready. We'll do some wonderful problems related to wave propagation. Everyone try to keep your calculators ready, and someone try to confirm the video and audio once. I'm also trying to check it in my preview also. Just give me a moment so that I can check in my preview. Someone, can you confirm, please? Yeah. Fine. So we are into EM wave propagation. EMFT module 2. EMFT module 2. EM wave propagation. We will try to solve some problems on wave propagation concept. This is lecture number 5 of the new series, EM wave propagation. Before we move in, let me introduce myself. I am Chaitanya Reddy, secured AAR 1931. I work as motivational speaker, pan-India from the past 12 years. An expert in field theory and communications. Before we further move in, let me introduce our Telegram channel, the official GATE Conqueror channel. The Telegram channel for the team is given here. The link is given here. You can take a screenshot, and after the class, you can find some time to join us on Telegram so that you can get a personal level assistance from the entire GATE Conqueror team, including the legendary KM Rao sir. We are into EMFT. It completed module 1 of EMFT. Which is elements of EMF theory. We completed elements of EMF theory. Module 1. Elements of EMF theory, which includes electrostatics, and magnetostatics. This electrostatics and magnetostatics put together is called as static field theory. In static field theory, mainly we are derived Maxwell equations for static fields. And also we went through time varying field theory. We are concentrated on two important concepts. Faraday's law and Maxwell contribution, also called as inconsistency of Ampere's law. Put together, we modified Maxwell equation and derived Maxwell equations for time varying field. These are the major concepts. Besides this, we also derived Laplace and Poisson's equations. We have derived boundary conditions. These are the major concepts I am trying to explain. And in this module, we have created a playlist with 40 videos covering all the basics. The 50 hours of recording is already done. It is available on our channel. You can access. I can proudly say that this will be the best playlist for EMF. Good afternoon, Bhaskar. Good afternoon. So, make a point to add this playlist. If you are from electrical background, then the complete EMF subject is done in this one playlist. Useful for both GATE and engineering services and other competitive exams. Along with that, module 2 is wave propagation. Now we are into module 2. Also we are finished substantial theory here. Almost we took 7 to 8 hours here also. Module 2 is about wave propagation. We are into this module now. Module 3 will be transmission lines. Module 4 will be waveguides. Module 5 will be antennas. Module 3 is transmission lines. 4 is waveguides, and 5 is antennas. Antennas we had covered under a playlist. Antennas Maha Marathon series. Antennas Maha Marathon series. 14 videos already recorded here, covering around 30 to 35 hours of recording exclusively on antennas. I can again proudly say that you will not get in this detailed explanation about antennas in any other playlist. 4 more hours of recording is left in antennas, will be done by this month end, covering all the previous year questions also. This also will be useful for GATE, engineering services and other competitive exams. This is already done. Here just 4 hours is left out. And within couple of days I'll complete wave propagation and parallelly start transmission lines and waveguides. So that is the idea, dear. How are you, Bhaskar? Ask everyone to join very, very soon, dear. We'll start up with the problems on wave propagation, because in this particular module we had completed EM wave propagation, in free space, sigma is 0, epsilon r is 1 and mu r is 1. Went through EM wave propagation, in materials, sigma not equal to 0, epsilon r greater than 1, mu r greater than 1. Let's see EM wave propagation. In good conductors, sigma far greater than omega epsilon. EM wave propagation in good dielectrics, sigma far less than omega epsilon. EM wave propagation in perfect dielectrics, sigma is 0, epsilon r is greater than 1 and mu r is greater than 1. Up to this point, theory is covered. Yes. Sorry dear, what you are saying? Plateau. VOM red means? I did not get you. Is it English? Yes, plateau. So we had completed up to this point here. Any doubt you can ask. We had completed up to this point. So we had seen analysis of wave propagation in free space, in perfect dielectric, in good dielectric, good conductor, and perfect conductor. Okay. We had done this revision. We derived all these concepts in our previous classes. Just a fast revision before you do numericals or problems. Yes, Jay, tell me. Bhaskar and others. Let us start with free space. For free space, how much is conductivity here? Anyone? For free space, how much is the conductivity? Yes. For free space, how much is the conductivity? For free space, conductivity is 0. Attenuation constant alpha is also 0. So let me complete conductivity here. For free space, conductivity is 0. For perfect dielectric also it is 0. For good dielectric, conductivity is less. For a good conductor, it is more. For perfect conductor, it is infinity. So conductivity journey from 0 to infinity here. Tuhin, how are you? Bhaskar, 0 correct. This is conductivity journey from 0 to infinity. Now alpha. For free space, alpha attenuation. For free space, in free space will the wave attenuate? No, 0. Perfect dielectric. Perfect dielectric, no attenuation, 0. For good dielectric, anyone, good dielectric, alpha depends on sigma. Sigma by 2 into under root of mu by epsilon. For good conductor, under root of omega mu sigma by 2. Sigma is very large value, so alpha is also very large. For perfect conductor, the wave cannot propagate. It means attenuation is infinity. Now you can see the journey of alpha. 0, 0. Sigma is less, therefore alpha is also less. In good dielectric, attenuation is less. In good conductor, attenuation is more. And for perfect conductor, not possible because attenuation is infinity. In perfect dielectric, conductivity is absolutely 0. You take if you take the example, it's an insulator. Perfect dielectric is an insulator where conductivity is completely zero, like rubber. Whereas good dielectric is like wood. It has some conductivity. Glass, good dielectric, it has some conductivity. Got it, Bhaskar? Next, beta. For free space, beta is omega into under root of mu naught epsilon naught. For perfect dielectric, beta is omega into under root of mu epsilon. Mu r is greater than 1, epsilon r is greater than 1. Therefore, beta value increases in perfect dielectric when compared to free space. In good dielectric, beta is omega into under root of mu epsilon into 1 plus sigma square by 8 omega square epsilon square. It is omega into under root of mu epsilon plus omega into under root of mu epsilon into sigma square by 8 omega square epsilon square. Clearly it is increasing in good dielectric. Then good conductor, beta is under root of omega mu sigma by 2. Sigma is very large value, it is still increasing. Perfect conductor, it is infinity. Now if you see the journey, where you have the least value of beta, anyone? Where do you have the least value of beta here? Where do you have the least value of beta? Yes, anyone? In this case, where do you have the least value of beta? Here the value of beta is least. Mu r is greater than 1, epsilon r is greater than 1. Slightly increases. Increases more here. Increases still more. Infinity. Is it clear? Next. Velocity. 1 by under root of mu naught epsilon naught. This is velocity of light in free space. C, 3 into 10 power 8 meter per second. Perfect dielectric. 1 by under root of mu epsilon. That is C by under root of mu r epsilon r. Means velocity decreases less than C. Here velocity for a good dielectric 1 by under root of mu epsilon 1 minus of sigma square by 8 omega square epsilon square. As conductivity has come into picture, it still decreases. Good conductor under root of 2 omega by mu sigma. Sigma is very large value. Still decreases. Perfect conductor. Velocity is 0. Now if you see the journey of velocity, highest value is velocity of light. Least is 0. Clear? That's for velocity. Next. Intrinsic impedance. Under root of mu naught by epsilon naught. 120 pi or 377 ohm. Eta under root of mu by epsilon 120 pi into under root of mu r by epsilon r greater than 1, therefore eta is decreasing. Highest value you got is 377 there. For good dielectric, under root of mu by epsilon 1 plus j times of sigma by 2 omega epsilon. Because conductivity came into picture here, eta will become complex. When conductivity is 0, impedance is the real value. When conductivity is not equal to 0, it will become complex. Here eta under root of omega mu by 2 sigma j times of under root of omega mu by 2 sigma. Again complex value. Because sigma not equal to 0. Here eta is 0. Is it clear? So that is how this formula is, you need to remember, which will be useful for you in solving the problems. Everyone, is it clear? Everyone. Tuhin, Bhaskar, others, everyone, is it clear? Everyone try to keep your calci ready. Is your calci ready, dear? First question. For a TEM wave, propagating in x direction in free space, for a TEM wave propagating in x direction in free space, y-axis, z-axis, this is EY or HY, electric field or magnetic field. And this is HZ or EZ, depends. So what's the question? For a TEM wave propagating in x direction in free space, the component of electric field along x direction is 0. You tell me, one combination is EY and HZ. Other combination is HY and EZ. In either of the combination, is there any EX value? X component of electric field is there? No, it is not there. 0 always. The statement is true. What is the use of real and complex for wave propagation? Real term and complex term determines reactance. The reactance can be inductive reactance or capacitive reactance. Again, it will be useful for matching purpose. We'll have an elaborate discussion very soon. If possible today, at the end of the session, we'll have a discussion on this. What is the importance of the reactance component, or else tomorrow. Clear? We'll have a discussion, 100%. Now, in either the combination, Ex is 0. So this is true. The component of magnetic field along x direction is 0. Is there any Hx component? No, Hx is also always 0. This is also true. Electric field and magnetic field are perpendicular to the direction of propagation. Direction of propagation is x direction. Electric field Ey, magnetic field Hz, they are perpendicular. Magnetic field Hy, electric field Ez, they are perpendicular to direction of propagation. True. The ratio of magnitude of electric field to the magnitude of magnetic field is always 120 pi. For free space, eta naught, intrinsic impedance of free space, is ratio of electric field to magnetic field, which is under root of mu naught by epsilon naught, which is under root of 4 pi into 10 power minus 7 by 10 power minus 9 by 36 pi. Solving this, you will get 120 pi or 377 ohm. This is also true. Which of these statements are true is asking. All the statements are true. Thereby option D is the answer. Is it clear? Three and 4. What happened to 3 and 4? You mean 3 and 4 are true? Not 1 and 2? All are true. 1, 2, 3, 4. All are true. Bhaskar. Thank you, thank you, thank you. Thank you, Nara sir, thank you. Bhaskar, all the options are true. Yes. All are true. Yes. Now, identify which of the following will not satisfy the wave equation. Identify which of the following will not satisfy wave equation. As I told you, a wave is something that changes its phase with respect to space and time. The change of phase with respect to time is given by omega t. The change of phase with respect to space is given by beta into the space direction. If it is x, it is beta x. If it is y, it is beta y. If it is z, it is beta z. Astrid, good afternoon. Now identify which of them does not represent a wave. This is sin x dear. Sin x cos t. Okay? A wave is something which changes its phase with respect to both space and time. The change of phase with respect to space is given by beta x or beta y or beta z. The change of phase with respect to time is given by omega t. If you are talking about a wave, then that wave must have omega t as well as beta x or beta y or beta z or a combination of this. Then only you can call it as a wave. Now see these four options and tell me which is not a wave. Which of these is not a wave? First, Astrid, Bhaskar, Raju, Tuhin, anyone? In the first option you have omega t, change of phase with respect to time, beta z, change of phase with respect to space. So this is wave 100%. Omega t, beta z, this is also wave. Omega t, beta z, this is also wave. Here actually omega is 1, beta is 1. This is a representation of a standing wave. Which options do not have, which options will not satisfy is saying, yeah, this will satisfy. A will satisfy, B will satisfy, D will satisfy. Who will not satisfy? In this there is only omega t, change of phase only with respect to time. Spatial orientation is not there. Then that means this cannot be a wave. This will not satisfy the wave equation. Option C is the answer. Got it? Very good, Bhaskar. Make 2.0 future. What's your name, dear? Yes. Y square is given there, not y. That's the reason. Yes, correct. Balu. You people get very innovative ideas to keep your name. Make 2.0 future. Next. In free space, E is given by 50 cos of 10 power 8t minus beta x AY volt per meter. Then find direction of propagation, intrinsic impedance, expression for magnetic field H, represent electric field and magnetic field in phasor forms, and also find beta. 5 questions are there in this. Yes, tell me one by one. Direction of propagation. What is the direction of propagation? No, dear. Y square is just trying to represent that beta x, beta y, beta z term is not there. that function will not vary with respect to space. That's it. Now, if you see here, this is of the form omega t minus beta x. Omega t minus beta x means the wave is propagating in which direction? Positive x direction. This answer is positive x. Next, intrinsic impedance. Given that it is free space. So what is intrinsic impedance if it is in free space? If it is in free space, what is the intrinsic impedance? Astrid, Balu. $120 pi. Very good, Bhaskar. 120 pi. Free space. Need not calculate. Or 377 ohm. Expression for magnetic field. Electric field is given as 50 cos of 10 power 8t minus beta x AY volt per meter. This implies E is magnitude of electric field E naught cos of omega t minus beta x AY volt per meter. But we know that the ratio of amplitude of electric field, amplitude of magnetic field gives you eta naught. Intrinsic impedance. Because free space is given. Therefore, magnitude of magnetic field H naught is E naught by eta naught. What is H naught here? H is equal to H naught cos of omega t minus beta x, wave propagating in x direction, electric field along y direction. So, magnetic field will be in which direction, dear? Tell me, magnetic field will be in which direction? Magnetic field will be in which direction? Wave is along x direction. Electric field is along y direction. So magnetic field will be in which direction? Yes, dear. Magnetic field will be in which direction? No, not y or z. Electric field already decided, no, Bhaskar. Electric field already decided, no, given in the question, y direction. Resistance opposes the current, and same manner to wave opposes by intrinsic impedance. This is right or wrong? Wrong. That is wrong, Balu. What is correct? We'll have discussion. Okay? Stay tuned. We'll have discussion. That is a very big concept you are asking. Okay? So, electric field is already in Y. So, magnetic field will be along Z, AZ, ampere per meter. Expression for electric field done. This is done. This is done. Represent field in phasor form. Represent. Now, what is H naught? Wait. What is H naught? E naught by eta. How much is E naught? 50 by eta naught. 120 pi. Therefore, H is 5 by 12 pi cos of 10 power 8t minus beta x into AZ ampere per meter. Is it clear? Represent the fields in phasor form. Who will have same units, dear? Balu? Who is having same units? Who is having same units? Balu, I did not got it. Same units for whom? Who is having same units? Please let me know, okay? So expression of magnetic field is done. Represent the field in phasor form. How to represent? Represent them in phasor form. E is equal to 50. Phasor form means time will not be there. 50 e power minus j beta x into ay volt per meter. H is 5 by 12 pi e power minus j beta x Az ampere per meter. Resistor and impedance. Okay. Resistor, other than opposing, will also do something else, Balu. What is that? Matching. Impedance matching. I will connect it, okay? I will connect it, don't worry. I'll explain for sure, don't worry. That's a wonderful concept. We'll have a discussion. Now, phasor form, is it clear? Writing it in phasor form is clear. Now find the value of beta first. Find the value of beta. What's the value of beta? The wave is propagating in free space. What is the formula? Free space. Beta formula, omega into under root of mu naught epsilon naught. Beta is omega into under root of mu naught epsilon naught. How much is omega? 10 power 8. 10 power 8 radian per second into under root of mu naught epsilon naught. What is C value? Velocity of light 1 by under root of mu naught epsilon naught, which is 3 into 10 power 8 meter per second. What is under root of mu naught epsilon naught? 1 by 3 into 10 power 8 meter per second. Substituting under root of mu naught epsilon naught value, 10 power 8 by 10 power 8 into under root of mu naught epsilon naught is 1 by 3 into 10 power 8. Implies beta is 1 by 3. So your answer beta value is 1 by 3. Answer is beta is 1 by 3. Is that clear? Bhaskar, Balu, everyone. Is that clear? Yes. Next. In air, E is equal to 20 sine of 2 pi into 10 power 70 minus y by 2 AY volt per meter. It is in air. So find eta. In air or free space, eta is eta naught under root of mu naught by epsilon naught, which is 120 pi or 377 ohm. Surojit, why can't you ask dear? You can ask. Find eta, direction of propagation. Anyone direction of propagation? See carefully and tell me direction of propagation. Surajit, can you help in direction of propagation? Did any time I told Surajit that I will not answer any doubt? Bhaskar, see the question carefully and tell me. See the question carefully and tell me. It may not be possible also. I know you are from AA, I know Surajit. But if you are preparing for engineering services, that will be useful anyways. Anyways, leave it. Don't. That's not a problem. You can ask your doubt, Surajit. And meanwhile, Bhaskar, see the expression carefully. There is a small problem in the expression. See here, the wave is propagating in y direction. The electric field is also given in y direction. This is invalid form. Wantedly I have given an invalid form to test you whether you will verify it or not. Got it? This is invalid form. Not valid. This is not possible. Not possible. So stop it here. Clear? In two semi-infinite conducting sheet in method of images, why the diagonal charge is taken positive? Very simple question. Very simple question. We'll answer. Okay? Don't worry. Two semi-infinite conducting sheets are given like this. Now, one charge Q is placed at a distance d. Am I right? According to method of images, at the same distance d, you'll have one more charge with opposite polarity. Clear? Now, if you take this side, here also it is clear. One second. Minus Q. Okay? At the same distance 2D. Now you tell me, Surajit, how much is this distance? This is day. This is day and this is day. How much is this distance? Root 2 into d. Root 2 into d. Now, when you are having only one sheet, you have one charge, a distance of d. One more distance d is to take one more charge minus q. Here, how many images are possible? How many images are possible here? This plane is making an angle 180. (360 by theta minus 1). (360 by 180 minus 1). One image is possible. Only one image charge is possible. Here in this case. This is only one image. When it is 180, there is only one image. When you have 90 degrees, 360 by 90 minus 1, 3 images are possible. For this is one image, and this is one more image. Now, the third image will be here. Got it, Surajit? (360 by n minus 1). You can take this example. This plane is having 180 degrees. 360 by theta minus 1. One image. This is one image. For this, 3 images are there. 1, 2, and one more will be here. But the rule is, for every 2D distance, the charge should be opposite. Here, distance is root 2d and root 2d is 2 root 2d, not 2d. Here it need not be opposite. But here, these charges are at a distance of 2d, which must be opposite. To keep this opposite, I must place plus q here. Because method of images says that at a equidistance of d or a total distance of 2d, then opposite charge should be placed. I know. Okay, good. You can also refer to the playlist here. Some wonderful playlist is already created on the platform Gate Conqueror channel. 40 videos are recorded, lecture number 1 to lecture number 40, especially for electrical people. Two D distance, dear Balu. This is D, no? This is D, 2D. D, 2D. Method of images rule. But here, root 2D will become 2 root 2D. Clear? No, it is there. Surajit, it is there. It is there. I explained this problem also. Red one. Red one means this one. Root 2D, dear. Pythagoras. Balu, apply Pythagoras. D. This is D. What will be this distance? This distance, Balu. Apply Pythagoras. This is D. This is D. Hypotenuse square is side square plus side square. 2D square. Hypotenuse is under root of this. Root 2D is this length. And plus root 2D. 2 root 2D. Yeah. But we have discussed this. And Surajit, 50 hours we have recorded this. The playlist is for 50 hours. More than recorded. The playlist is for 50 hours, which is far greater than the recorded one. So this was on method of images. Yes, Balu, is that clear? Now, given electric field E is equal to (25 cos of 10 power 8t) minus 3x plus 4z ay is asking find the propagation direction. Please find out. Yes, find out the answer. First, what is the answer? E is equal to standard form. E naught cos of omega t minus beta into direction. The direction of electric field. The direction of the wave. Omega t minus of we should write to find the resultant direction. 25 cos of 10 power 8t minus of 3x minus 4z ay. The resultant wave is displacing along 3ax minus 4az. Thereby option C is the answer. Is that clear? Any doubts? Next, if an EM wave attenuates to 50% of initial value for a distance of 4 meters, if an EM wave attenuates to 50% of initial value at a distance of 4 meters, what distance the wave should travel if the wave is to be attenuated to 20% of initial value? So very clearly attenuation is there. So try to write the wave in standard form. E is equal to E naught into e power minus alpha z. It can be any direction, okay? I am taking z direction example. E power j of omega t minus beta z. Just I am trying to assume that the wave is propagating in z direction with electric field along x direction and magnetic field along y direction. So this will be my equation. This is change of phase with respect to time. This is change of phase with respect to space. So this is basically phase component. This is the amplitude component related to attenuation. So considering the amplitude component for calculation of attenuation, E is E naught into e power minus alpha z. What is given? The electric field is attenuated to 50% of initial value. Initial value is E naught. It is attenuated to 50% of initial value at distance 4 meters. So at z is 4 meters. E is 0.5 E naught. Make substitutions. 0.5 E naught is E naught into e power minus alpha 4. E naught and E naught get cancelled. 1 by 2 is equal to e power minus alpha 4. Implies e power alpha 4 is equal to 2. Alpha into 4 is equal to ln of 2. Alpha is one by 4 of ln of 2. Is it clear so far? No problem, dear. Surajit, I am more than happy to help you. What would I do? What my basic work is to help you people, no? I am really happy that you had asked me. Anyways, all the best, all the best. Any doubt, any time, you can contact me. Nothing to worry, okay? Now, what distance it should travel so that the wave is attenuated to 20% of initial value. Let Z is x meter. The wave is attenuated to 20%, 20 by 100, 0.2 of initial value, 0.2 E naught. So 0.2 E naught, substituting here, is equal to E naught into e power minus alpha z. E naught get cancelled. 2 by 10 is e power minus alpha z. Alpha into x, x is the distance I need to find. 10 by 2, that is 5 is e power alpha x. Alpha x is ln of 5. Alpha is 1 by x of ln of 5. Equate both of them and find the answer. Through God of Machines. Surajit. This is not skin depth. Balu, please refer yesterday's class. I explained about skin depth very clearly. Today also we'll do numerics on skin depth. This is not skin depth. Okay? Solve it and tell me the answer. Balu, Bhaskar. One by 4 into ln of 2 is 1 by x into ln of 5. Distance x is 4 times ln of 5 by ln of 2. Find the answer and tell me. I am very hungry. You're eating food, I am eating your brain. What's the answer, Balu? .28 meter. So when the wave has travelled a distance of 4 meter, it has got attenuated to 50% of the initial value. If it needs to attenuate to the 20% of initial value, it needs to travel a total distance of 9.28 meter or further a distance of 5.28 meter. But it is not asking further distance, it is asking only total distance. Therefore, answer is 9.28 meter. Is it clear? Next question. The distance in meters, Balu, skin depth concept. A wave has to propagate the distance in meters a wave has to propagate in a medium having a skin depth delta, having a skin depth of 0.1 meter, delta is 0.1 meter, so that the amplitude of the wave, amplitude not power, amplitude of the wave attenuates to 20 dB. Attenuation alpha is given as 20 dB. Is asking what distance it has to propagate so that attenuation will be 20 dB. He wants distance. Can anyone tell me how delta and alpha are related? How delta and alpha are related? Alpha, attenuation constant is 1 by delta. 1 by 0.1. Therefore, alpha is 10. Given alpha is 20 dB. Yes, correct. Because alpha in decibel. Alpha value is given because it is amplitude. 20 log of alpha to base 10. It's 20 log of 10 to base 10. 20 dB. Correct. So, we can say that alpha is 10. First conclusion is alpha is equal to 10. Now, I want to find the distance a wave has to propagate in a medium having skin depth 0.1 meter so that the amplitude of the wave attenuates by 20 dB. What is the formula for alpha? Attenuation in decibel in terms of amplitude of electric field. Alpha in decibel is 20 log to base 10. E naught by E. Alpha in decibel is 20 log to base 10. E naught by E. Is there any other further clarification required that how we got this formula, or shall I move ahead? Please tell me. Is there any further clarification required? Please tell me. If at all any further clarification is required, please tell me. If you consider power of 10 watt, you want to convert power in decibel, it is 10 log power to base 10. 10 log 10 to base 10. 10 watt power, decibel conversion is 10 dB. Okay. Power is 20 watt. Power in decibel. Ten log power to base 10. 10 log 20 to base 10. It is 13 dB. Power is 40 watt. Power in decibel. 10 log 40 to base 10. One second. It will be easy for you to compare if I write one below the other. 10 log 40 to base 10. 16 dB. $80 10 log 80 to base 10. Is 19 dB. If power is 100 watt, ten log 100 to base 10. Ten log power to base 10. 10 log 100 to base 10. 20 dB. $160. You can verify if you want. It will be 22 dB. Similarly, if power is 1000 watt, ten log 1000 to base 10, that will become 30 dB. This is dB conversion. Listen carefully. Clear? Okay, now you see. If you observe carefully, power was 10 watt, decibel 10 dB, power is 20 watt, decibel is 13 dB. That means when the power got multiplied by 2, it got doubled. How much increase you can see here? Plus 3 dB. That means plus 3 dB improvement means power will get doubled. So I can say power will get doubled for every plus 3 dB. For every plus 3 dB, the power will get doubled. I'll write the rule here. For plus 3 dB, the power will be multiplied by 2 times. And if you see here, 10 dB to 20 dB. For every plus 10 dB, the power will be multiplied by 10 times. The shortcut now. Plus 3 dB means power is multiplied by 2 times, doubled. Plus 10 dB means multiply by 10. Similarly, plus 20 dB means multiply the power by 100. Similarly, it goes on. Plus 30 dB means multiply the power by 1000. It goes on. That's power relation. Is it clear? On the other side, when you are moving from here to here, 13 dB to 10 dB, for every minus 3 dB, the power will become half. For every minus 3 dB, power is becoming half. Minus 10 dB, power is dividing by 10. Minus 20 dB, the power value dividing by 100. $30 dB, power is dividing by 1000. It goes on. This is the basic table you need to remember. The same calculation, if you take in voltage, it will be 20 log. So what happens is, in voltage, every plus 6 dB, voltage is multiplied by 2. Minus 6 dB multiplied by 1 by 2. Everyone please tell me, is this clear? Everyone, is it clear? Because we are considering amplitude here, this is important. Now I will justify this formula. When E is equal to E naught, substituting here 20 log 1 0, attenuation is 0 dB. No attenuation, both are same. E is half of E naught, means 50% it is gone. Alpha in decibel is 20 log of E naught by E is E naught by 2. How much answer you got? 6 dB. Attenuation is 6 dB. Why? Value became half. Value became half. Got it? That's why I can say this formula will be suitable for all the cases. This formula will be suitable for all the cases. Given attenuation is 20 dB. Alpha in decibel 20 is 20 log of E naught by E. One is log to base 10 E naught by E. E naught by E is 10. E is 1 by 10 of E naught or 0.1 E naught. E is 0.1 E naught. So what you got? You got E is 0.1 E naught. E is E naught into E power minus alpha Z. 0.1 E naught is E naught times of E power minus alpha. Alpha is 10 into Z. E naught get cancelled. 1 by 10 is E power minus 10Z. 10 is E power 10Z. 10 times Z is ln of 10. Z is 1 by 10 of ln of 10. ln of 10 is 2.3 by 10. Z is 0.23 meter. That should be the distance. So that alpha will become attenuated to 20 dB. The complete logic here is depends on this table. If you are doing power calculation for 10 dB, loss, the value will be 1 by 10. Because this is voltage calculation, for 20 dB loss, it will be 1 by 10. If you know that logic, you need not waste all this time. Directly 20 dB, amplitude calculation, 1 by 10. E will be 1 by 10 of E naught. Finished. E will be 0.1 E naught. This you will get directly, without doing any calculation. It's a logic. Once you get this, you can write this expression directly. E is 0.1 of E naught. Why? Amplitude calculation 20 dB attenuation is given. For power calculation 10 dB attenuation means 1 by 10. For voltage calculation 20 dB attenuation means 1 by 10. Direct answer. E is equal to 0.1 E naught. You need not use this formula also. Directly you can write E is equal to 0.1 E naught. From here you can continue. Within 1 minute you will get this answer. Because all this time will be saved in the exam. Because now you know the concept. Is it clear? This is a wonderful shortcut. GSR, Balu, Bhaskar, Surojit. Is it clear? Plus 20 dB multiplies 10 times. Minus 20 dB divided by 10 times. Double of these numbers. Here minus 3 dB, no? Minus 6 dB. Minus 10 dB. Minus 20 dB. Clear? Refractive index of glass is 1.5. Refractive index of glass is 1.5. Find the length of a beam of light. The frequency of 10 power 14 Hz in glass. Assume velocity of light is 3 into 10 power 8 meter per second. Find the length of the beam of the light. Means it's asking us to find the wavelength, lambda. Refractive index of glass is given as 1.5. Refractive index will decide the velocity with which the wave propagates in that particular medium. Refractive index formula n is equal to C by V. From this V, velocity with which the wave is propagating through that medium is C by N. C is the velocity with which the wave propagates in free space, or it is the velocity of light 3 into 10 power 8 by 1.5. So the velocity with which the wave propagates in glass is less than the velocity of light. Here it is given as 2 into 10 power 8 meter per second we got. So velocity we got it as 2 into 10 power 8 meter per second. It's asking us to find the lambda. You know, frequency F is equal to V by lambda. V is the velocity with which the wave is propagating in the medium. We got it through the value of N, which is 2 into 10 power 8 meter per second. Now, we can easily find lambda, which is V by F. V is 2 into 10 power 8 meter per second. Frequency F is 10 power 14. This is 2 into 10 power minus 6 meter, that is 2 micrometer. Wavelength is 2 micrometer. Option C is the answer. Is it clear? Good. Fine. Next. the magnetic field intensity vector of a plane wave is given by h of x comma y comma z is equal to 10 sine of 50,000 t plus 0.004x plus 30 ay, where ay denotes the unit vector in y direction. The wave is propagating with a phase velocity of, is asking find the phase velocity. How to find? This is like h is equal to some magnitude h naught times of sine of omega t plus beta x plus some angle of reflection. Angle at the point of reflection. This does not matter. So it is of the form h naught of sine of omega t plus beta x. Omega t plus beta x means the wave is propagating in the positive x direction or negative x direction. Omega t plus beta x means the wave is propagating in the positive x direction or negative x direction. Omega t plus beta x means the wave is propagating in the negative x direction. Omega t minus beta x means positive x direction. How to understand this is, and what is the value of beta here? Omega t minus beta x. Wave is propagating in the positive x direction. Beta is positive. Omega t plus beta x, wave is propagating in the negative x direction. Beta is negative. Beta can be beta and direction. Both can be positive or both can be negative. One positive, one negative is not possible. Why? Because if you consider a wave like this propagating in the positive x direction, phase shift is 0, pi by 2, pi, 3 pi by 2 and 2 pi. If the wave is propagating in the positive x direction from this point to this point, the phase difference is pi by 2 and the wave is propagating in the positive x direction. Now on the other side, if it moves from this point to this point, beta is minus pi by 2, 0 minus pi by 2. It is minus pi by 2. Direction is negative x direction. That's the reason I am saying you that both beta and direction can be positive or both can be negative. Here in the given question, it is in the form of omega t plus beta x. Means direction is minus x. Beta will also be negative. But here omega is 50,000 radian per second and beta is minus 0.004, not plus. You want phase velocity omega by beta. 5 into 10 power 4 by minus 4 into 10 power minus 3 minus 1.25 into 10 power 7 meter per second minus 1.25 into 10 power 7 meter per second. Option C is the answer. Is it clear? Everyone, is that clear? Next question. A plane wave of wavelength lambda traveling in a direction making an angle 30 degrees with the positive x-axis plane wave making an angle of 30 degrees, the positive x-axis, with the positive x-axis, this is 30 degrees with the positive x-axis, 90 degrees with the positive y-axis, with the positive y-axis. The E field of a plane wave can be represented by electric field of this plane wave is required. This is the EM wave. I want the electric field component of this EM wave. It is making 30 degrees with the positive x-axis, means it will make 60 degrees with the positive z-axis. The direction of propagation, orientation, let it be A. Now if you see the displacement along x direction, in x direction the unit vector is Ax. Then to find the displacement we find A dot Ax mod of Ax cos of angle between this direction of propagation of wave A and Ax 30 degrees into cos 30. That is A into cos 30 root 3 by 2. But what is A? Displacement with respect to x direction. That is beta x. Beta root 3 by 2 into x. Beta is 2 pi by lambda into root 3 by 2 into x. That is root 3 pi by lambda x. That is the displacement along x direction. If you take displacement along y direction, A dot Ay mod of Ay cos of 90 0. There won't be any y component. You can see here no y component. Perfect. No y component. Perfect. Z, A dot Az, again mod of Az cos of 60, A into 1 by 2, A is now displacement along Z direction, beta Z into 1 by 2, 2 pi by lambda into Z into 1 by 2, pi by lambda Z. Electric field value, wave propagating in free space, E is equal to E naught into e power j of omega t minus, how much displacement you got? Root 3 pi by lambda into x minus pi by lambda into z. This must be your equation. E is equal to E naught into e power j of omega t minus of root 3 pi by lambda into x minus pi by lambda into z, direction of electric field component Ay. So option A is your answer. Is that clear? If you take the general form, E is equal to E naught into e power minus of one second. Yeah, right in the general form, E is equal to E naught into e power j of omega t minus beta dot r, where beta is beta xax plus beta yay plus beta zaz, r is xax plus yay plus zaz. Beta dot r is beta x into x, beta y into y, plus beta z into z. Where beta, mod of beta is under root of beta x square plus beta y square plus beta z square. And beta x is beta cos theta x, beta y is beta cos theta y, beta z is beta cos theta z. So here very clearly, if you expand this, the standard form E is equal to E naught into e power j of omega t minus of beta xx beta y into y plus beta z into z. Beta y is beta cos theta y. What is theta y here with respect to y? 90 degrees. Cos 90 is 0. Therefore, beta y is 0. No beta y term. Beta x is beta cos theta x. Beta cos theta x. Cos 30 with x axis. That is beta into root 3 by 2. That's beta x. That's why it is 2 pi by lambda into root 3 by 2 into x. That's why it is root 3 pi by lambda into x. Substituting E is equal to E naught into e power j of omega t minus of root 3 pi by lambda into x plus beta z, beta cos theta z 2 pi by lambda cos 60, that is 1 by 2. So beta z is 2 pi by lambda into 1 by 2, pi by lambda. Beta z into z is pi by lambda into z. That's the reason why you get this as the final answer. E is E naught into e power j of omega t minus of root 3 pi by lambda into x plus pi by lambda x. Minus I am multiplying inside. So I got E is equal to E naught into e power j of omega t minus root 3 pi by lambda into x minus pi by lambda into z. This is lengthy process. Trying to take the standard form. E is equal to E naught into e power j of omega t minus beta dot r. Taking beta value, taking r value, doing beta dot r. You get the standard form. Beta x into x plus beta y into y plus beta z into z, which is beta dot r. Substituting back, you get E is equal to E naught into e power j times of omega t minus of beta x into x plus beta y into y plus beta z into z. Again, we need to find the formula for beta x, beta y, beta z. Beta x is beta cos theta x, beta y is beta cos theta y, beta z is beta cos theta z. Basing on the angles given, you need to find beta x, beta y, beta z. Substitute back here. This is lengthy process. What I told here is a simple shortcut. A dot ax. Got it? A is beta x. A dot ay, A dot az. Finished. Is it clear? But this is more conceptual. Once you know this, if there are any variations in the given problem, then also you can do it very easily. Is that clear? Rest of the problems, we'll try to do it in the next class. Unacademy provides you two paid platforms. One is Plus subscription, other is Iconic subscription. In Plus subscription, you got to have the FaceTime of legendary faculties in the form of live classes, weekly test, structured courses, unlimited access, rank improvement batches and crash courses. In Iconic, you have a dedicated personal coach for one-on-one guidance, dedicated doubt clearing educators, preparatory study material, personalized test analysis, study booster sessions and study planner. Iconic, remember, includes all the features of Plus also. If you're going for a Plus subscription or an Iconic subscription, I recommend you to go for a no-cost EMI where the total cost will be divided by number of months. Very much student friendly, will be useful for the students, and you can use the code GCR10 to get an extra 10% off. Not only that, we are just dividing the total cost by total number of months without any extra cost, but also we are giving an extra 10% discount. With the Iconic subscription, you get a personal coach for one-on-one guidance, giving you 1:1 live mentoring, increasing your chances of getting a top rank. And this is the Republic Day special deal. We are giving you 6 months free extension. That means with 12 months subscription, we'll give you 6 months extra extension. 18 months subscription will give you at the rate of 12 months. Moreover, you can use my code GCR10 to get extra 10% off. But today is the last date. Today before 12 in the midnight, you need to avail this offer deal. The code is GCR10. And you can start learning with the India's best faculty. And if you are talented, then you can go for the talent test, that is a comeback, which is live quiz competition where 20 questions will be asked, 60 minutes will be given, and it is held on this Sunday, January 30, 11 a.m. It is separately held for mechanical, civil, electrical, EC and CSID. And those who top, we are ready to give away scholarship worth of rupees 4 crore. And not only that, irrespective of your performance, 100 lucky participants will also stand a chance to win all these gifts. And there is no fees for this combat. It is free. Just you can join this combat using my code GCR10. We are conducting all India mock test here. Complete January we have conducted. The last mock test for GATE 2022 is on January 30, Sunday. You can also enroll this for free using my code GCR10. Once you enroll into the All India mock test, you can understand, you can assess where you actually stand among your peer students. among your competitors. And this is a wonderful opportunity for GATE 2022 aspirants as well as GATE 2023 aspirants, because these mock tests are designed by India's topmost faculty. These are the special class features here, where you have interactive live classes. Interactive live classes in the special classes. We have polls for the learners. We have raise hand option. You never miss a class once the notification is on. And once the class is done, you can download the lecture notes. You can access anytime and anywhere. These are the new feature, that is Unacademy Ask a Doubt feature, through which you can ask unlimited number of doubts and get them clarified in your preferred language. It is very, very easy to upload your doubt also. These are the new batches here, started yesterday, that is 27th of January, that is today. Where GATE 2024 for ECE, explained in English. Ascent GATE 2024 for electrical. Ascent GATE 2024 for ECE. SPAR GATE 2023 for electrical. SPAR GATE 2023 for ECE. Evolve GATE 2023 for ECE. Evolve GATE 2023 for electrical. All of them started today. And not only this, these are the batches in the other branches. Each one of them you can join using my code GCR10 to avail extra 10% off dear. Thank you all. Thank you all for joining us. A very big thank you from Unacademy. A very big thank you from the channel Unacademy. Very big thank you from Unacademy. A very big thank you from the GATE Conqueror channel. Very big thank you from our head, legendary KM Rao sir. Very big thank you from myself. Have a very good day, dear.